Hello, this is Shakil Ahmed. In this tutorial series, I will focus on applying Python for statistical analysis. In today's world, most of the data scientists focus on working with Python instead R. Although R also has many attractive features, Python is more easy and it can produce more attractive graphics and data visualizations. So people mostly focus on applying their statistical analysis problems with Python. So you can work with Anaconda. Anaconda is a package, basically full software package available for analyzing data on Python. But luckily, we have another platform that is Google Colab, hosted by Google, and you can do your analysis online, and you can work with a Jupyter notebook, and you don't need to install anything. You can just work, and it is free to uh, use. You don't need to pay. So in this tutorial, I will show how we can start with uh, data analysis with Google Colab. So let's start. Just write in Google what is just write Google Colab. You will get the Google Colab, and you need to have a Google account attached to your Google Colab. So if you are already working on some uh, directory or you have already created a notebook, you can open your notebook. Otherwise, you can create a new notebook if you are start as a fresh. I have I had some notebooks already in my Google account, so I will try to open them and I will show how we can analyze our data. So I have these Python codes. This is on already saved on Google Drive. Statistics in Python I have created. So we can I can just open it. So now we are on Google Colab. Here you can edit your text, you can create your codes, and you can do your analysis. So I have this data set already installed here, and if I will show how you can upload your data and you can read your data. So first of all, for reading your data set, you need to import the Pandas package, Pandas library. That is, I have imported as Pandas as PD. So you can just run this. It is now run without any error. Then I need to uh, upload this data. I need this data set on the Google Colab. So just I will check if I have already uploaded this data, then it will open. It's giving some error. It means the data is not available here. Then you can just see the files. So I don't have the stroke data here. Basically, I want to read this stroke data that is in CSV format. If you have other formats, you can just write here. So I have this strokes data in CSV format. So I can upload this data set from my computer that is saved here, strokes data, and open it. So you can just, okay, and now I have the strokes.csv. So now I can try to read this data. Now I can read the data. And then the next step is to see the first few cases of your data you can read, and you can just run this. So I have a data set on different patients. These are patients' IDs, and these are gender, age, hypertension, heart disease, your merit, and these are all that mixed type of data set. And you can generate a code with your data frame. Just you can generate codes online, and you can also see all the recommended plots for your all the variables. Let's see. Just click on this. So within a click, you don't need to write any code. You can just see what type of recommended type of graphics for your all the variables you have. So for example, for age variable, the recommended type is age, this a histogram, and for hypertension there is a bar chart, and for heart disease again a bar chart. There are missing values, we need to remove them before analyzing, but for now you can see what type of graphs can be used. You can see the variable types basically from these graphics. So you can see all the types, and these are basically residence type versus ID, and these are interactive graphics between two variables. So you can see all that, and then uh, we can do the statistical analysis. You can also check for the shape of your data. Uh, so for that, you need to import numpy. You need numpy package as np, and then uh, you can create your new code here. You can just over over the this side, you can see, you can just run this, and then you have option of adding a new code. For example, you want to see np dot. I think you can see the shape of your data set. This tells the dimension of your data. So we have 5,110 cases on 13 variables. And then uh, we can find different summary statistics under the NumPy package. For example, I can see the variance and the mean. For the variance for age variable, this is a continuous variable, so we can find the mean. And the average glucose level, this is also a continuous variable, so we can find uh, a mean as well. And if the more interesting thing is for continuous variables, the variables on quantitative scale, we need to obtain a summary statistics, 5 number summary statistics. So within the data frame, and this is my data, I have these variables. For example, I'm just putting three variables: age, BMI, and average glucose level. And I want to see the summary statistics for these variables. So I can just write df, then this is basically I am as extracting the variables from data frame, and I have a list of variables. I have three variables, so I created a tuple for uh, three three variables within the data frame, and then dot describe, it means I need descriptive statistics. So it will give the count summary, basically number of observation in each variable. This will remove the NS where there are empty values or NAs, then it will automatically remove. For BMI, we have only 4909 observations, and for glucose level and age, we have no missing values. Then we can see the mean, standard deviation, minimum, first quartile, second quartile, and third quartile, and then maximum. Five number summary statistics, including counts, mean, and standard deviation. So you can see these, and you can also see the distribution of these variables. Uh, these are two-dimensional distributions, and these are all about the continuous variables. So when you have discrete variables, then we can do, for example, we can do the analysis for subgroups. Then we can do, for example, I want to subgroup the data according to, I need mean for a subgroup of males. So what I do, I first restrict the observations to only males, and then within male I extract only one variable, that is age. If I want to keep all the variables I have extracted above, then we can write age. We can again copy the three variables, and then we can write describe. Let's see. And this will give the summary statistics for subgroup of males only. So here we have only 21 2015 observations for age and BMI. We have only 2011 observations, and average glucose level we have again no missing observations. And you can see the distribution, suggested charts for these again using just clicking here. But these are not authentic. You need to, while applying appropriate chart type, you need to clean your data and remove the missing observations, and then you need to you need to do proper statistical analysis, proper data visualization using your knowledge, not just relying on AI. These are AI based basically. You can create a more sophisticated table just clicking that option, and I will show you again. So here is an option. You want to create a sophisticated table, you can just click on this. So you will have a table. You can copy this table, you can save this table, you can and just this is publishable format of your data. So this is all about the uh, basic extraction of data and doing statistical analysis. And you can create the box plot for these observations, these variables. As we are dealing with continuous variables, we can find the box plots. You can find box plot without restricting on the data, and if you want to restrict data, then you can create a group by gender. That is basically I am making the group, stratifying the data into male and female. So it will give you two type of histograms, one for male and one for female. So then group by gender dot box plot, whatever type of plot you want, you can just write. If you want histogram, you can write histogram, and then column, you are extracting the columns from your data frame. This is basically a data frame stratified by a male and female. This is so. If you want to stratify with some other variable, you can just change this, and then I need a histogram for these three variables as we just summarized above. So you can just run this and then, so it's giving a histogram for these three variables for by gender. So we have three types of gender: female, male, and others. But for others, we have only one observation, I think. So that is not meaningful. So you can see the three box plots for three variables for females and for males. So that's interesting. And then you can find the histogram for for the continuous variables just using the np dot histogram option. So but you need to decide the number of beans here. So for histogram, you can just specify your bean and then plot x-axis and plot y-axis. Here is the full code. You can just, you need to import matplot library that we will discuss later again. So for different type of plottings, you need a library called matplot library that is I have imported as a PLT. So then within PLT we have option of histogram, and I'm making histogram of age, and number of bins is 6. If you want to make histogram for some other variable, you can just change. And then your X label is the value, you can just name some, and your Y label is are the frequencies, and plot title is frequency distribution. You can write histogram. So then you need to give a command of plt dot show. Then you can open and you will see a histogram, and you can increase the number of bins. So these are the value of x-axis, level of x-axis, and this is level of y-axis, and this is the title. So this is all about the basic analysis when you have a continuous variable or a quantitative variable. When we have categorical variable, then we need to create frequency distributions, then cross tabulation, and then we will go for statistical inference involving categorical variable and continuous variable. So for now, this is enough. And if you have any question, you can always write in comment section. Thank you for watching.